Hi folks, I hope you're well again, and in this video we're going to work through the worked examples in the course notes for specific latent heat. Okay, so they are starting on page 8, and we have number 1. Which of the following liquids has the larger latent heat of vaporization? Vinegar, which requires 195 kilojoules to vaporize 500 grams, or benzene, which requires 320 kilojoules to vaporize 800 grams. So if we think about what the definition for specific latent heat is, L is equal to the amount of energy per kilogram. So if we work out what the equivalent of 1 kilogram would be, and what we're going to do, so we're going to take the amount of energy and we're going to divide it by the mass of substance. And so for vinegar, we have, obviously, your formula EH is equal to ml. We're going to have EH is equal to ml, and we're going to rearrange for L, which will give us EH over m. So we'll have 195 kilojoules, so that's 195 times 10 to the power of 3, like so, divided by 500 grams, which is 0.5 kilograms. And that will give us 390 kilojoules. So 390 kilojoules, which would be 3.9 times 10 to the power of 5 joules per kilogram. So that is the specific latent heat of vinegar. And then of benzene, we're going to do the same. So L is equal to EH over m. And we have 320 and that's 0.8 kilograms. 320 divided by 0.8 will give us 4 times 10 to the 5 joules per kilogram. Okay, so now we've got to watch. The question actually asks which of the following liquids has the larger latent heat of vaporization. And so I'm just going to put over here there. Therefore, benzene has the larger value. Okay, done. Moving on. Question 2 asks us that at 357 degrees C, mercury boils into a vapor. We don't actually need the temperature at all. What we're interested in is the mass and the amount of energy. So there's 20 grams of mercury, and it will take 5,880 joules of energy to do that. So specific latent heat of vaporization of mercury. So we're going to calculate L is equal to EH over m, and we'll have 5,880. 20 times 10 to the minus 3 because it's 20 grams, and so we will have convert to kilograms here, and then we'll just work out divided by, and we will get, so that's 2.94 10 to the power of 5 joules per kilogram. Okay, question 3. Water in a kettle is brought to boil at 100 degrees C and then heated for a further 2 minutes. The power of the kettle is 2 kilowatts. How much heat energy is added to the water during these 2 minutes? So we have now, we have a power and we have a time. So we're going to be looking for energy is equal to power times time. Now let's just get a table here because we've got a few conversions to do. So we'll have E is equal to question mark, P is equal to 2 kilowatts, which is 2000 watts, and time is 2 minutes, which is going to be 120 seconds. So our total energy will be 2000 times 120, which will give us 240,000, which I will put down just now as 240 kilojoules. Okay. Determine the mass of water converted to steam during this time. Well, we have, so we're looking for mass. AH is equal to ml. Therefore, mass would be EH over L. Now, the L value, remember, we're converting water into steam, and so we're going to have the specific latent heat of vaporization for water, which is 22.6 times 10 to the minus 3. We're going to use 240. $240,000 divided by 22.6 times 10 to the power of 5, and that will give us 0.106, so we could say 106 grams. Now it says, why would it take longer in practice to convert this mass of water to steam? Well, this is assuming that this is the heat energy that you put in, or the element of the kettle is going to produce. But as I previously talked about in specific heat capacity, although it produces this amount of heat energy, some of that heat energy does not make it into the water and will indeed go to heating up the surrounding or the sides of the kettle, and then on to heating up the air that surrounds the kettle. So you're going to have heat energy lost to the surroundings, and that's why it would take a longer time. So we could say heat energy what you'll find is that that's pretty much the stock answer to just about everything in properties of matter, where we're having in real life, in practice, or why would it be a greater amount of energy, why would it take a greater amount of energy, and the stock answer is that heat energy is lost to the surroundings. It's always a good idea to pay, in exam questions, to pay close attention to how many marks this is worth, because that will give you a good idea about the level of detail that you need to make for your answer. So yeah, it would be sufficient just to say that heat energy is lost to the surroundings, and that is your worked examples. Okay, thanks for watching, and I'll see you again soon. Bye bye.